Good day and welcome to Geometry Unit 6, and we're going to talk today about angles of polygons. If Polly's gone, did her angles go with her? Okay, so first thing we need to do is some definitions. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. So as you can see here from point P, I have a segment running from here to P to R and another segment from P to S. Those segments are diagonals because they are non-consecutive, right? Q is a consecutive vertex. We don't want it. That doesn't work because it'll make a side. And from P to T makes a side also. So a diagonal, again, is a segment that connects any two non-consecutive vertices. Okay, so you'll see here we have a triangle, and there are no diagonals in triangles because every vertex is consecutive to every other vertex. So that doesn't work there. So let's keep in mind, though, that the sum of the angles of a triangle always add up to 180. Keep that in mind as we continue working through some more polygons. So now I have a quadrilateral, and you'll see here that if I start at this vertex here, I can only create one diagonal. But in creating that one diagonal, I end up with two triangles. Let's move on. So here I have a pentagon. Again, from this vertex here, I can draw a diagonal here, and I can draw a diagonal here. And because of that, we end up with 1, 2, 3 triangles. So the last shape we're going to talk about here is our hexagon. So here's our vertex, and we end up with a triangle, or a diagonal here, one diagonal here, and another diagonal right here. So we end up with 1, 2, 3, and 4 triangles. Now they're going to all spin away. So let's build a table. So this is in your guided notes. In our left-hand column, we have the polygon, the name of the polygon, the number of sides, then the number of triangles formed, and the sum of the interior angle measures. So the column on the right is what's really important here, because this is what we're talking about here. These angle measures, what do they all add up to? So a triangle, there's 3 sides, 1 triangle. Sum of the interior angle measures is 180. Quadrilateral has 4 sides, but 2 triangles would be formed from a diagonal. Therefore, it's 2 times 180, or 360. Pentagon, 5 sides, 3 triangles. 3 times 180 is 540. Hexagon, 6 sides, 4 triangles. 4 times 180, or 720. An n-gon, what's an n-gon? Well, an n-gon is, we're saying, hey, what's the rule here? So if the number of sides is n, the number of triangles is going to be 2 less. If we look down that column, every time we have 2 less than the number of sides. So n minus 2. So the sum of the interior angle measures is n minus 2 times 180, which brings us to so now we have polygon interior angle sum theorem. So basically, what this theorem says is the sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180. So we would look at this pentagon and we would say the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle E is equal to 5 minus 2 times 180, or 540. All right, so now we want to take what we've already learned and solve for x. And let's go and keeping in mind that the sum of the interior angles of this pentagon, right, we would use n minus 2 times 180, so the number of sides is 5 minus 2 times 180, that's equal to 3 times 180. So that gives us 540 degrees is the sum of all of those angles. Now you want to solve for x, so go ahead, set up an algebraic equation and solve for x, and I'll check with you shortly. Okay, so I'm going to start here at angle M, and I'm going to say 3x plus 14 plus 3x plus 14 plus 2x plus another 2x plus 142 is equal to 540. Now that seems like a lot, so let's go ahead and combine like terms. So we get 3x plus 3x is 6x plus 2x is 8x plus another 2x. That gives me 10x. 14 plus 14 is 28. 28 plus 140 is 170. And that's going to equal 540. So now we're going to do some algebra. So we combine like terms. Now we're going to subtract 170 from each side. And I worked down my columns. 10x, 170 minus 170 is 0. 540 minus 170 is 370. And I'm going to divide each side by 10. And my final answer is that x is equal to 37. Okay, this one's a lot tougher to set up. So I'm going to walk you through this one and make sure you're paying attention to what we say and what we do here. So the measure of the interior angle, right? So this is the interior angle. This is important, of a regular polygon is 135. So a regular polygon means all of the angles in that polygon are equal and all the sides are equal. So they want you to find the number of sides. So we know the formula is n minus 2 times 180 to find the total. But I don't know how many sides I have, but I know that each angle is 135. So 135 times the number of angles is going to give me that measurement. So now we're going to do some distributive property here. I'm going to multiply this 180 times n and then 180 times negative 2 in this next step. So I've got 180n minus 360 equals 135n. So now I can do some algebra. I've got to get all of my values away from the 360, right? So I've got to get all the n's to one side. So I'm going to go with minus 180n. And I'm going to end up with a negative value here, and that's okay. So because we've got negative 360 here equals negative 45n. So I'm going to divide each side by negative 45. And I end up with 8 is equal to n. So my answer is the number of sides equals 8. Okay, so here I have a triangle, right? And this angle here is 60 degrees, and this angle here is 85 degrees, and this angle here is 35 degrees. And I know if I add all these three angles together, they're going to total 180 degrees. But the interesting thing is their exterior angles all add up to 360. So let's see if this is true for a quadrilateral. So on a quadrilateral here, so this one would be 98 degrees. This one would be 67 degrees. This would be 140 over here. And this one here would be 55. And if I take all these values and add them together, I get 360 degrees. So that works out, but these exterior angles, again, all add up to 360. Now, we can go through the same process again, and there's no problem doing that, but that's kind of a waste of time at this point. But trust me here when I say those interior angles are going to add up to 540. But here's the interesting thing. The exterior angles all add up to 360 degrees for this pentagon. So what do you think is true for polygons? No matter how many sides a polygon has or how many angles, right? Because the number of sides equals the number of interior angles. The sum of the exterior angles is always 360. Okay, so we set up our equation as 2x plus 9x plus 6x plus 139 is equal to 360. So I 2x plus 9, 2 plus 9 is 11 plus 6 is, that's 17x plus 139 equals 360. So I'm going to subtract 139 from each side. And 360 minus 139 is 221. So 17x equals 221. Now I divide each side by 17. And I get x is equal to 13. Okay, go ahead and use what you learned and solve for x on this problem. Go ahead. Okay, so we'll start here with 2x plus 5x plus 2x minus 5 plus 3x plus 10 plus 6x minus 5 equals 360. I got rid of my parentheses right off the bat. So 2 plus 5 is 7, plus 2 is 9, plus 3 is 12, plus 6x's, that's 18x. And then we come over here and go minus 5 plus 10 gives me plus 5, and 5 minus 5 here is 0. So that's done, and we got equals 360. So we're going to divide each side by 18, and we get x is equal to 20.